Ho ho ho, and welcome to another day here on TryHackMe. We are doing Advent of Cyber. It is day number 12, and today we're looking at web timing attack. If I can steal the money, I can steal the joy. So we are dealing with a bank called Wareville Bank, and the learning objectives are: understand the concepts of race condition vulnerabilities, identify the gaps introduced by HTTP2, exploit race conditions in a controlled environment, and learn how to fix the race. So it's basically how to fix the vulnerability. We started the machine, we got the IP address, and we're booting up the attack box that we need to access this server with, which is hosted on port 5000. Web timing and race conditions. Conventional web applications are relatively easy to understand, identify, exploit. If there is an issue in the code of the web application, we can force the web application to perform an unintended action by sending specific inputs. These are easy to understand because there is usually a direct relationship between the input and the output. We get bad outputs when we send bad data indicating a vulnerability. But what if we can find vulnerabilities using only good data? What if it isn't about the data, but how we send it? This is where web timing and race condition attacks come into play. Let's dive into this crazy world and often hidden attack surface. In the simplest form, a web timing attack means we glean information from the web application by reviewing how long it takes to process our request. By making any tiny changes in what we send or how we send it, and observing the response time, we can access information we are not authorized to have. Race conditions are subjects of web timed attacks that are even more special. With the race condition attack, we are no longer simply looking to gain access to information, but we can cause web application to perform unintended action on our behalf. Okay, web timing vulnerabilities can be incredibly subtle. Based on the following research, there is some sort of research through Portswigger, which is the company that creates Burp Suite. Response time differs between from 1300 to 5 nanoseconds. Have been used to stage attacks. Because of their subtle nature, they can also be hard to detect and often require various testing techniques. However, with the increase in adoption of HTTP2, they have become a bit easier to find and exploit. The rise of HTTP2 was created as a major update for HTTP. The protocol used for web applications, while most web applications are still use HTTP 1.1, there has been a steady increase in the adoption of HTTP2 as a faster, better for web performance, and has several features that evaluate the limitation of HTTP 1.1. However, if implemented incorrectly, some of these new features can be exploited by threat actors using new techniques. A key difference in web timing attacks between HTTP 1 and HTTP 2 is that HTTP 2 supports a feature called single packet multi-requests. Network latency, the amount of time it takes for the request to reach to the web server, made it difficult to identify web timing attacks. It was hard to know whether the time difference was due to a web timing vulnerability or simply a network latency difference. However, with a single packet of multiple response requests, we can stack multiple requests on the same TCP packet, eliminating network latency from the equation, meaning time difference can be attributed to different processing times for the request. This is explained more in the animation below. So we have an animation here, and you can basically follow that and see like how time is progressing. Now we have two watches, same time, and we're getting more responses. So yeah, it's a little difficult for this to make sense when you read the text to understand that, but this is how it works. With network latency a thing of the past, only server latency remains, making it significantly easier to detect timing issues and exploit them to recover sensitive information. Typical timing attacks. Timing attacks can often be divided into two main categories: information disclosure or race conditions. Now, so I'm not talking too much about information disclosure, but race conditions is a similar business logic flaw that a threat actor can cause the application to perform unintended actions. However, The issue's root cause is not how web application process requests, making it possible to cause the race condition. For example, if we send the same coupon request several times simultaneously, it might be possible to apply it more than once. So for the rest of the stack, we will focus on race conditions. We will have a look at the time to check or time to use, talk to, flaw. Let's use an example to explain this. So the example right here, talking about how this is actually exploited. You better have to research that a bit in order to better understand it. When the user submits their coupon code, it is actually a code of replication. In the actual code of replication, at some point we perform a check that the coupon is valid and hasn't been used before. We apply the discount, and only then do we update the coupon code to indicate that it's already been used. In this example, between checks and the coupon is valid. If the coupon is valid and our update is coupon being used, there are a couple of milliseconds where we apply the coupon. While this might seem small, if a threat actor can send 2 requests so close together in time, it might happen that before the coupon is updated in request, it has already been checked in request 2, meaning that both requests will apply the coupon. This is a thing that is very normal in race conditions, is that you force the computer to do something before it's validated, and this is why we need to fix the race later on. Winning the race. And this, now you understand how a basic concept relates to race condition. Let's explore how the vulnerability occurs in real world scenario. For this, we'll take an example on the Wareville banking application hosted on this application address. The application allows users to log in and transfer funds between the accounts. Let's go ahead and just open the browser right now in the attack box. I already copy pasted this, I think so. If not, I'm going to redo it just like that. While waiting on the Firefox web browser, we can continue. Then just pick in the IP address. So before we start intercepting requests, we need to configure the environment so that as a pen tester, all traffic from the browser is routed through Burp Suite. Let's go ahead and open up Burp Suite. We already have Foxy Proxy installed right there. It is currently disabled. And what we need to do in the attack box is just to press Burp, and then we actually direct all traffic to Foxy. We direct all traffic to Burp Proxy through Foxy Proxy. Foxy Proxy is just another pretty plugin you can install, an extension, whatever you're going to call it, for your browser, and it's pretty easy to install. If you don't know how to use it, it's pretty easy. It's just to click it and then add a new one and direct all traffic to 127.0.0.1 and to the port of 8080, and the rest of information you can fill out doesn't really matter. Give it a name it Burp or Cookie, whatever you like, maybe Burp is a better name. So now that we have that directed, start Burp, and now that Burp is started, then we are already ahead of the tutorial. So it's a powerful vulnerability scanner to intercept and modify requests. For this exploitation, we can access Burp Suite in the attack box, in the desktop or the attack box. You will see Burp Suite icon as a blah, blah, blah. Yeah. So once you click it, and now we have it open. It looks like this. So I'm gonna try and just make it a little smaller so we can actually have it there. Alright, so we are there. We click start Burp. Boom, we're done. So on Burp, it is started. We'll see in the main interface tabs called Proxy, Intruder, and Repeater. It is Proxy, Intruder, and Repeater. Now, I had success earlier by changing the settings on the Burp and going to the, let me just see if I can find it. I think I just typed font or something like that. And then I could increase the font size to something bigger, let's say 18. That should do. No, I did not have success with that. Display user interface font size, there we go, and 18. And that definitely should change all the user interface so we can better see it on your screen. So now that this is there, updating and restart. So we can definitely see that Burp is right here. We got the target, proxy, intruder, and repeater. On the target, on the scope and sitemap, we can learn more. On the proxy, on the intercept, it says intercept on, which is basically when it's on, it's blue. It means that you're intercepting all the traffic that are that are being sent from our browser through Burp. If it's off, we can browse whatever we like from our browser without going through Burp. So now that this is done, we need to, inside Burp, click settings, tab right, we'll see Burp's browser option available under tools. So we're going to go to tools now and allow Burp's browser to run without a sandbox option. So I think it was like settings, somewhere there, settings, and then delete the word font or type and tools. And under tools, somewhere under Burp's browser options, there we go. We're gonna click allow Burp to run without a sandbox. So there we go. So that is fixed now. Alright, and after allowing the browser to run without a sandbox, we would now be able to start the browser with a pre-configured Burp Suite proxy on the browser. Yeah, we can do that. What we can also do is to intercept and press enter, and then you see boop, it got like a pop here and basically intercepted the requests on the browser, and from that we can definitely go and direct different kind of traffic types. So we can definitely go ahead and check this out if we wanted to. We can also go ahead and check this out, and what we can do is we can send it direct on the proxy interceptions. You know, we can send it to by right-clicking to intruder, repeater, sequence, and so on. So if we send it to repeater and press intercept off and go back to repeater, you can see that this is the actual request that is sent, like get slash, that means / the root of the website using HTTP 1.1, and this is the port. And if I actually send this right now, I will get a response back, which is in the other tab, and then I can see the response, which is the exact same thing as we saw. Sometimes render works, sometimes it doesn't, depending on this attack box configuration, but I'm going to leave that. So the pretty one is the one we're going to see in the most occasion, the text, and all the HTML we see here is basically the thing we see right here with the login, account number, and password. So we can just scroll down a bit, and this is difficult to see because it's so small. There we go. So login, you know, account number and password, that's the actual web page. All right, so now that is done, we can once you browse the URL, all requests intercepted can be seen on the HTTP proxy HTTP history. So we can go into proxy. You can always go to history and see the previously intercepted URLs. You can also click it right there, and of course, depending on the screen size, it can be a bit bigger. I should definitely, you know, fold this out to extend. We go with view in full screen, because that will probably make it easier for us to check out. And now that I have such a big font, I should definitely go in and just change the font just a tad, because it is just too big. So 16 is probably better. There we go. So now that we have font number 16 of that size, I can put it right there, and then I can easier switch back and forth, and it's easier for us to see. So there's a small back and forth here we can switch between. So now I need to go back, and I need to exit split window right there. So we have the window right there, and now we need to scroll down a bit to find where we came to. And we came to this part right here. So we are logged in, and we are seeing a login page and application scanning. So as a penetration tester, one key step in identifying race conditions is to validate function involving multiple transactions or operations that interact with the shared resources, such as transferring funds between accounts, reading and writing to database, updating balances, etc. Blah, blah, blah. Example me to log into the bank. So account number 1110 and the password tester. So we'll go back here and tester. We're gonna log in, not now. And we'll see that we have a balance of $1,000. So we rich. So we can now transfer some money back and forth to the target account number, and amount to transfer. That's basically the amount of dollars into some other account. This is what we see right here. Once you're logged in, You will see two functionalities: logout, which probably does not involve simultaneous tasks, so I guess that's true. The next is funds transfer, which includes deducting funds from the account and adding them to another account. As a pen tester, this could be an opportunity for an attack. We will see in detail how, as a pen tester, you can exploit the vulnerability. So, verifying the funds transfer functionality, we will browse the bank application and perform a sample transaction inside the browser. It will generate a GET and a POST request, and whatever request we make will be passed through Burp Suite. As shown in the figure, our current balance is 1,000. We will send $500 to another bank account with a bank account number 111, and while doing that, all our requests will be captured with Burp Suite. So click on the transfer button and we will see something like this. So let's go ahead and go back and transfer 5 to 111 and transfer 500. I'm going to go back here to the intercept and press intercept on. I will press transfer, and you will see here in the interceptor that I have this one right here. It should also be in history. Now that we have transfer and success, I can basically just say forward because I don't want to do anything with it, and then just intercept off right now because we have everything in history, and we will get this transaction ID. Okay, so checking out the let's see, it's login and can know transfer. So we can check out this transfer right here. We have some post request, as they also told us about, sent with some sort of login cookie. That's our identification. And then basically it says account number 111 and amount 500. That's really how that performed. So that's typical normal. And then we have the dashboard, which is fine, and a success. And success. So two different kinds of success variable. And then we are receiving the transaction ID, which is sent to us. I think the dashboard right here to definitely have it somewhere. Anyways, let's go back to the tutorial and see what we're going to do now. Now let's review the HTTP fund transfer post page request, logged in, and we just did that. And basically it says the same thing as we see it on the proxy there and this one, and they show exactly what to look for. Now the above figures shows that the transfer endpoint accepts a post request with a parameter of account number and amount. There's a 2-1 right there marked number 4. The Burp Suite tool has a feature known as a repeater that will allow us to send multiple HTTP requests. We will use this feature to duplicate our HTTP post request and send it multiple times to exploit the race condition vulnerability. Right click on the post request and send to repeater. So go back into Burp right here and right click the transfer and say send to repeater. Now it's sent to the repeater. And the repeater can send multiple requests at the same time. I'll send one just by sending one. But let's follow the tutorial. So now we did that. Navigate to the repeater tab where I find the post. We can change the account number from 1 and account value number for 500 to other values as shown in the request below. Now they are showing the same, so I'm going to leave it there as it is right now. Place the mouse cursor inside the request of the repeater and tap and press Ctrl R, duplicate the tab, press Ctrl R 10 times. Okay, so we have already one here. It's the old one I did, so delete that one. That one, Ctrl R, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus type number 2. That's why it's to 11. Now that we have 10 requests ready, you would like to send them simultaneously. While one option is manually click send button in each tab individual, we aim to send them all parallel to do this. Click the plus icon next to the request 10 and select create tab group. So we're going to click the plus icon, create tab group, and we will definitely go ahead and click all of those that we have right there. All 10, okay? Create. Now that is done, we have a tab group, and this tab group consists of these 10 HTTP requests. All right. Name it fonts. No, we don't read. Fair enough. Let's just edit and name it fonts. That's what it says. So now it says fonts the same way as it does in the tutorial. Now we're ready to launch multiple copies of our HTTP post request simultaneously to exploit the race condition vulnerability. Select send group in parallel last byte sync. In the drop down next to send button, once selected, the send button will change to send group parallel. Click this button to send all duplicate requests in our tab group at the same time. So we're going to click. Send group in parallel. And now we can click select group parallel. And does it tell us to do that? One send button, click the send button, all duplicate request. So we click it now. It is now clicked. It is now done. So navigate to tester account in browser and check the current balance. You will notice the tester balance negative because we successfully transferred more funds than we were able to in the account. Let's go ahead and do that. Go back, update, and we'll see that we have the negative amount of money because we transferred more money than we actually had. It was the case of multiple requests being interpreted at the same time, and one of them or more of them sometimes, could be caught in the condition and not execute. In this particular case, it was time enough for all 10 to all 10 or 9 duplicates to be executed. So by duplicating 10 requests sent in parallel, we in instructing the system to make 10 simultaneously requests, each deducting $500 from the tester account and sending it to the account 111. In the correctly implemented system, the application should have processed the first request, locked the database, and then processed the remaining requests individually. However, due to race condition, the application handled the requests abruptly, resulting in a negative balance in the tester account and an inflated balance in account 11.1. Verifying through source code. Now, suppose you're a penetration tester with access to the application source code, as in a white box testing scenario. In this case, you can identify potential race condition vulnerability through the code review. By analyzing the code, you can pinpoint areas where multiple database operations are performed without proper transaction handling. Below is the Python code that handles the font racer. You have the Python code right there, and you can go ahead and check it out. We're going to read the text. In the above code, if user balance amount larger than amount, the application first updates the receipt balance with the command SQL statement followed by commit. Then if it updates the sender balance using this and commits again. Since these updates are committed separately and not part of the single atomic transaction, there is no logging or proper synchronization between these operations. This lack of a transaction or logging mechanism makes the code vulnerable to race conditions, as concurrent requests could interfere with the balance update. Time for some action now. That we understand the vulnerability, you should set glitch in validating it's using the account number 101 and the password glitch. So attempt to exploit vulnerability by transferring over $2,000 to account number 111. So let's go ahead and log out and log in to glitch. I cannot type. There you go. Not now. And now we should definitely go ahead and see the account balance. So what we should do now is remove all these tabs here in Burp Proxy. I know it's a tedious process. Long live clicking. There we go. And now we're going to go to, we can just basically say 111 and send $1. That would be, I don't know, that's probably fine. So transaction complete. Go to proxy, history, transfer, send to repeater. Go to repeater. Notice this is the one. We will now send 500 to that account. Isn't that true? So we're going to send $2,000 to account 111. So I'm going to take all this now. I'm going to press Control R 4 times. So I have 1, 2, 4 times. I'm not going to go ahead and click create tab group. I'm going to give it a name and call it I win. Drop down, create parallel, send parallel. It is now done. And I will then update, and I got the flag because we won. I will put in the flag here down below. Complete 2 other tasks. Only the flag, not all the text. So now we did that. We actually exploited the room. We transferred a lot of money. I can click out, log out, close the machine like this, go back and always terminate the machine on TryHackMe. That is a good tendency to not cause extra stress on the servers. And this is Santa me talking to you. So what I have to say now is that be mindful of your code and think about race conditions. And as always, I will say